Good morning, everyone. Good afternoon, wherever you are. Welcome to the webinar that we will present today. The webinar is entitled How to Get Zhaga-D4i Certification for Luminaires, Sensors and Communication Nodes. And we have presenters from the DALI Alliance, DECRA and the Zaga Consortium. I'm Tim Whitaker. I'm the Marketing Manager for the DALI Alliance. And I'm going to start by giving you a quick when my PowerPoint frees up, there we go, a quick set of admin details. So our presentations will last for 40 to 45 minutes, and then they will be followed by a Q&A session. If you have any questions, please type them into the Q&A box on your screen. Please use the Q&A box rather than the chat. We will provide written answers to the questions after the event, but we'll try and answer as many questions live as we can. The presentation materials and also a recording of the webinar will be available after the event via both the DALI Alliance and the Zaga websites. So our agenda today looks like this. We have presentations from 3 experts. We have Scott Wade from the DALI Alliance. We have Dave Dentonier from the Zaga Consortium. And we have Jaap Neusink from DECRA. I'm going to give a quick introduction. I'll keep it very brief. This slide is probably very familiar to you. It summarizes the key features of the Zhaga-D4i ecosystem, specifically for outdoor lighting. And this is based around a Zhaga-D4i Luminaire, which contains D4i drivers, and in this case, 2 Zaga receptacles. D4i ensures that Luminaire energy and diagnostics data is available from the driver. And D4i also simplifies the addition of sensors or wireless communication nodes to the Luminaire via the Zaga connectors. What does this mean? Well, it means we can have intelligent Zhaga-D4i Luminaires that can communicate with citywide networks, for example. It means future-proof Luminaires that can be easily upgraded. And of course, it means a Zhaga-D4i certification program, which is the subject of our webinar. So what's the value of certification? Well, the Zhaga-D4i program relies on independent verification of test results. Products are traceable, available from multiple suppliers. Certification allows the use of the Zaga and D4i logos, and this sends a clear message of future-proof Luminaires, the availability of Luminaire energy and diagnostics data, and plug-and-play interoperability. So without any further delay, I'm going to hand over to Scott and take over and make the first presentation. Scott, over to you.
Thanks, Tim. Good morning, good afternoon, or good evening. Let me, Tim, if you can just remember to pass the ball.
Yeah.
Just give me a second until I share. Okay, so I'm Scott Wade. I'm the Technical and Certification Manager for the DALI Alliance. I'm going to take you through the D4i part of this webinar, including a look at the products, testing, and certification. First, we'll have a quick look at DALI, just an introduction to DALI and the DALI Alliance, then the trademarks, the D4i requirements specifically, and briefly looking at testing and certification. So DALI, the basics. DALI is the industry standard protocol, which just means it's a language for bidirectional digital communication between lighting control devices, and it is dedicated to lighting with a rich feature set. DALI is technically managed in the open standard 62386, IEC 62386. DALI 2 is the latest version of the DALI protocol, and DALI 2 and D4i certification is driven by DIIA, the Global DALI Alliance. And with this certification, it ensures interoperability through testing and certification with trademark use. And you can see the DALI 2 and D4i trademarks on the right, and the DALI trademark on the bottom left. These are all controlled by DIIA for our members. The DALI Alliance itself is an open global consortium of lighting companies aiming to grow the market for lighting control solutions based on DALI. We're also known as the Digital Illumination Interface Alliance, but rebranded recently to DALI Alliance, which is a bit quicker to say. We have more than 260 members worldwide, and our members are the industry leaders in lighting and control. Membership allows certification or registration of products, and currently we have over 1,600 DALI 2 certified products, and that includes D4i, and more than 1,360 DALI version 1 registered products. Membership allows DALI, DALI 2 and D4i trademark use as appropriate. So the trademarks are used by our members, and the original DALI logo, you can see there, is used on registered control gear. And we use registered to mean DALI version 1. So these products, which can only be control gear, the drivers, are DALI version 1 tested, and then they're listed on the DALI website. Also, the members can use the DALI trademark to promote the technology, so for marketing use and promotion use. DALI 2 is used on certified products. So these have passed the DALI 2 tests, but also they've been verified by DIIA before certification is granted. And all certified products are listed on the website, so you can check if a product is really certified. D4i is also used on certified products, and these have passed the DALI 2 tests with verification, again, by DIIA, exactly the same as DALI 2. But D4i products also include some specific features that are optional for DALI 2. So D4i is DALI 2 with some extra features which are also tested and verified. Luminaires using DALI, DALI 2 or D4i components are also able to use these trademarks. The detailed requirements for these are in the trademark guidelines document, and there's an additional one for D4i trademark use. And the following slides explain the main requirements for D4i control gear, control devices, and luminaires. So D4i is an extension to DALI 2. Control gear are required to have a minimum set of functionality for D4i. So DALI 2 has lots of optional parts to it. D4i has some of those are no longer optional, they're mandatory. And control devices also require functionality to aid plug and play. And this is all especially for intra-luminaire use, where DALI is inside the luminaire. And an example D4i application is the streetlights application, and in collaboration with Zaga, luminaires meeting the requirements can be Zaga D4i certified. And this makes it easy to add or upgrade sensors or communications nodes to the luminaires, the use of this receptacle and the plug and play capability. And that future-proofs the luminaires. So let's look at the different product types and the D4i requirements and D4i meaning for those. So firstly, D4i control gear. It includes all of the following. So all of these different parts of the standard. So all control gear has to have these first two parts. D4i control gear are all LED drivers, so they must include part 207. And then these four parts here give extra functionality. So there is a DALI bus power supply built in with a memory bank that allows you to read out the capabilities of that and control it. And then we have luminaire data, energy reporting, and diagnostics and maintenance data. Optionally, the control gear can include an auxiliary power supply, and that's in this specification. That's a 24-volt power supply, and it's used in the luminaires for powering higher power control devices. It could be a city-wide communications node. Also, the control gear can include other IEC 62386 parts. They're all optional as well. Now, regular or associate membership of DIIA is required to allow certification and trademark use on the control gear. For the control devices, D4i for control devices, they implement part 351. This is Luminaire mounted control devices. And that's the most recent addition to the certification. Part 351 describes 4 types. We call them A through D. So these are the main characteristics of the 4 types. A, B, and C are multi-masters, and A is externally powered, B is bus powered or externally powered, and C is purely bus powered. Now these need certain combinations of application controller, that's the brains of the system that makes decisions to control the lights, and they may optionally have a sensor or input device built in, such as a light sensor or movement sensor. And type D is a single master, so single masters can only operate on their own. They cannot operate with a second device, a second control device. Again, they optionally have a sensor built in, and these can be bus powered or externally powered. Now, some Luminaires will support 2 of these devices, so they could have 2 receptacles, 2 connectors for these. And for outdoor, that's what A and B is targeted at, so types A and B. So you could have one of type A and one of type B attached to an outdoor Luminaire. You can't have 2 A's or 2 B's. You can either have one of these or one of each. And for indoor applications especially, you can have a C and a B. So that's one of either of those or one of each. And of course, any of these could have a type D attached on its own. You cannot have another one of these with a type D. As with the control gear, control devices, to be tested or certified, you need a regular or associate membership of DIIA. So that's for certification and for trademark use. Then for Luminaires, they include up to 4 LED drivers, the D4i Luminaires, and these drivers meet the D4i requirements, and D4i drivers already include a bus power supply integrated within the driver. There's also basic Luminaire information pre-programmed into these D4i drivers in the D4i Luminaire. Optionally, the Luminaires can include D4i control devices, an aux supply, that's the 24-volt supply, and that's required, for example, for Zaga-D4i outdoor applications. And they could also include emergency lighting control gear. Luminaires need to meet the D4i requirements to allow the D4i trademark to be used, but there's no certification of Luminaires by DIIA, so we don't certify. We specify the requirements for these Luminaires, but we don't certify them. We can also list them, that's optional. Any membership type, regular, associate, or community membership, allows this D4i trademark use on Luminaires. Also allows DALI2 or DALI trademark use according to the types of devices inside the Luminaires. Just an example to show how, it's just a block diagram to show how a 2-node outdoor Luminaire might look. So to start with, this large rectangle is the Luminaire itself. There's the driver, and it has LEDs for the lamp. Now the drivers are D4i, and they include these parts of the standard. So all the bus power supply and the additional data parts. Optionally, there's an auxiliary power supply, and that follows this part of the standard. It might be in the driver itself, or it may be a separate product inside the Luminaire. Then we've got the power and the data connections inside the Luminaire. So we have a DALI bus inside the Luminaire going to these 2 connectors that you can see in this example. On the top connector, we've put a wireless communications node. So that could connect to a city-wide network. Again, that's D4i, which means it implements this part of the standard, part 351. And on the bottom, it might be a sensor node. Maybe it's a movement sensor, for example. So that's just one example of how a Luminaire might look with two nodes attached. Now, the data specifications that you get with D4i control gear provide various information. There's Luminaire data, so the GTIN, that's the global trade item number, information about light output, CCT, CRI, and light distribution is all there, and enables asset management. Part 252 gives energy and power information. So this is real-time power and energy data. And part 253 is diagnostics and maintenance. So it's data about the control gear itself and also the lamps, including failure data and runtime data. And that enables predictive maintenance. So an outdoor example. So in the factory, the Luminaire data would be programmed into the drivers that are inside the Luminaire. So all that information is then accessible later. In the field, automated commissioning is possible because there's lots of data here, and with a node plugged into the top, you've got remote access to these Luminaires. So it might be set up from the city control room. During operation, you've got performance monitoring. So for example, the energy data could be used for billing. You've also got predictive maintenance because of all the diagnostics data that's built in to the control gear. Okay, so testing. We have two official DALI testers that you can use for testing, the Probit Lab and the Probit Lab 2. Only the Probit Lab 2 is available now, but if you have the Probit Lab, you can still use that. Compliance testing can be carried out by DIIA members or by an accredited test house. And test houses are also DIIA members. Now the test houses are listed. So if you go to this web page, go to the DIIA website, this web page will list the currently accredited test houses. So these ones are the current. So there are 9 current test houses. This is for D4i and other DALI 2 testing. So once you've tested the product, you've got certification, and how that's done depends on the type of product. So for LED drivers, the control gear, D4i certification is obtained as a DALI Alliance member. So you must be a DALI Alliance or DIIA member to obtain this. So once you have your test results, the members submit the product information and the test results through their DIIA website link. For control devices, the first stage is the same. To get D4i certification, again, you test or use a test house, then submit the information through your website account, and we verify the results. So both of those in DIIA, we will verify the results and the information and then grant the certification. At that stage, they're listed as D4i products on the website. But there's a second step for this, for control devices, to get the Zaga D4i certification. And that step is done by the Zaga organization or the Zaga test house. So to get Zhaga-D4i, both 1 and 2 are necessary. For Luminaires, in DIIA, we give the trademark usage requirements, and you need to meet those to be allowed to use the D4i trademarks on the Luminaires. And again, there's a step for Zaga-D4i through the Zaga test house. So there's extra information required by the Zaga test house to grant that certification. For the connectors, of course, that's not related to what we do in DIIA. That's purely within the Zaga organization and the Zaga test house. And that's a very convenient point for me to hand over to the Secretary General of the Zaga Consortium, D. Dantenier.
Scott, great talk. Every time I hear you speak, I learn something new. So I have to do a few things. I would like to start a video and say hi to everybody. And thanks for tuning in to this webinar. And let me also share my presentation with you. and it should be all right here. Okay, let me then take the opportunity to talk you through the Zaga part of this Zhaga-D4i interface story. First, some words of introduction. I'm Dave Engineer. I'm Secretary General of the Zaga Consortium, doing this as part of my job at Certify. Zaga then is an industry consortium, some 300 members, and its mission is to create interface specifications for components of LED luminaires. The aim of this is to enable multi-vendor ecosystems of interoperable products and to create trust in multi-vendor interoperability, that products from different vendors work well together. We also have a testing and certification program run by independent test houses. And we've created quite a few specifications, and we've shown this in the table. But today we focus on the specifications that specify the interface between a luminaire and the sensor or communication node, developed jointly with the DALI Alliance. This interface supports plug-and-play interoperability between a luminaire and the sensor or communication node. And we believe that our standards and certification are key to assure the market about multi-vendor interoperability and have the potential to drive volume and scale in connected lighting. But let me first explain the relation between DALI and Zaga in my words. So the DALI parts were already expertly explained by Scott. Definitely nothing to add from my side. These specify power, communication, data and control aspects of the interface. What Zaga does or has done is specify the mechanical aspects of the interface. Next, it references the D4i specifications for the power and control and luminaire tests. And then it does the pin assignments. And this is done in our so-called book 18 for outdoor and our book 20 for indoor. And this picture I've shown a lot already. It illustrates the main elements of the Zaga D4i interface standard for outdoor. It was also shown by Tim. And at the core are the Zaga D4i luminaire and the Zaga D4i node. The node is a sensing or wireless communication node, and the Zaga D4i luminaire has a receptacle that allows us to easily add the node to the luminaire. The receptacle fixes the node and connects it through the DALI bus to the D4i driver or drivers. As also shown, a luminaire can host up to 2 of such Zaga D4i interfaces. Typically, the interface on the top will host a communication module to integrate the luminaire in a light management network. The interface on the bottom may then host a sensor. However, the standard specifies the interfaces only and leaves room for many use cases also beyond lighting and provides a great platform for innovation and smart city. I'm not going to say a whole lot about Book 18 technology, as we communicated a lot about this already, except for one thing. There's currently an extension ongoing in Zaga. Zaga is making an update of its Book 18 specification, and this will give luminaire OEMs an additional option. The extension also specifies hybrid luminaires that have an NZC 13641 interface in conjunction with the Zaga interface. Typically, the ANSI interface on the top, Zaga interface on the bottom. And the advantage is that a luminaire OEM may also use existing lighting controllers focused on on-off metering and still add innovative features such as environmental sensing and area security monitor to their luminaires. And the extension is so that it still meets the Zaga interoperability promise. Because this interoperability promise is key to our approach, it is essential that nodes and luminaires from different vendors work well together. Therefore, we have developed a certification program to test and certify luminaires as well as nodes. And in conjunction, we have a trademark and logo program that allows the use of the trademarks for certified products as a sign of this interoperability. The test technically verify the key requirements for luminaires and nodes to work well together. And the Zhaga-D4i logo combination can be used to label the luminaires and the nodes and to advertise that these products are being part of this ecosystem. We will come to talk about exactly how this is done. But let me first repeat a message already by Tim. Zhaga-D4i certification adds value to the product. It provides confidence in the multi-vendor interoperability, that nodes and luminaires work well together, nodes and luminaires from different vendors. It is also a tool for communication. For end customers, it makes it easy to source into this multi-vendor ecosystem. For specifiers, it makes specification a lot easier. And for manufacturers, it's a great tool to indicate that a product is part of this ecosystem, thus adding value to the products. It's a great tool to show that your Luminaire is future-proof and able to host next generations of nodes, as well as current generations of nodes. We've also ensured that Zhaga-D4i certification is easy to do. For Luminaire manufacturers, it's supported by a number of certified components. The connectors, in this case, the receptacle and the D4i driver. For node manufacturers, it's the base plates, it's the caps, but it's also the D4i certification that is the first step in the Zhaga-D4i certification of the nodes. We've developed a simple flow for that, and we have excellent and knowledgeable test houses in place to help you, guide you through this process. Let us now turn to the indoor situation. The main elements of the Zhaga-D4i interface for indoor luminaires are quite similar to the situation for outdoor. Again, there's a Zhaga-D4i luminaire and a Zaga-D4i node. Again, the nodes embed sensor and communication technology and can be simply added to the luminaire. With a connector, a node connects via the DALI bus to the D4i driver. Despite similarities, there's also marked difference between outdoor and indoor specification. And here we focus then mainly on the mechanical aspects, Scott having already covered power and control aspects that are different for indoor and outdoor. Notably, an indoor Zhaga-D4i luminaire can host only one node. Then the standard provides for rectangular nodes as well as cylindrical nodes. Next, the standard does not define a receptacle. Rather, the mechanical interface at the Zhaga-D4i luminaire is defined via a keep-out zone and a connector. The node can then include the fitting system to fit the node into the luminaire as determined by the requirements of the application. The standard in all features 4 of such keep-out zones to meet the requirements of the different technologies. So we have rectangular interfaces, rectangular keep-out zones, for a smaller one for rectangular modules with small volumes and in different orientation. A bigger one for rectangular modules requiring more volume and surface like gas detectors or complex presence detectors. And we have cylindrical modules, as already widely used in the field, with adjustable orientation and minimum surface. And we have L-shaped modules enabling ultra-flat luminaire designs. So these interfaces are defined via keep-out zone in the luminaire, and of course, conversely, by a demarcation module for the model for the nodes. Next, the interface comprises a connector, which has a 2-pin interface and a socket. Poka-yoka features prevent incorrect mating, and the connector provides fingerproof protection. The connector is essential to the if it fits, it works promise of the Zaga D4i interface standards. It ensures easy and safe replacement. It ensures plug and play connection, and it ensures that the future luminaire is future-proof and can be easily equipped with next generations of Zaga D4i nodes for indoor. Again, what was true for outdoor also holds for indoor. The key promise of the Zaga D4i specification is that luminaires and nodes from different vendors work well together. Again, also for indoor, we have a Zaga D4i test and certification. and the trademark and logo program that allows the use of the trademarks for certified products. I could repeat myself and Tim from before that. This really adds value to your Luminaire and to your nodes. And again, we've made this easy to do, supported by an ecosystem of components that you can integrate into your Luminaire and D4i certification to help the Zaga-D4i certification of your nodes. Now let me turn to somewhat more specifics of the Zaga-D4i certification for Luminaires. I will here focus on book 18 because I think that is currently the example with which we have most experience, and I focus on book 18 with the Zaga receptacles. By and large, the process for book 20 or for the extension of book 18 is similar. So the Zaga-D4i certification for Luminaire is open to Zaga associate and regular members that have signed the local license agreements, but these come free of charge with your Zaga membership. The products use certified components, as I mentioned, drivers, connectors, receptacles, base plates, caps. And manufacturers connect to test house for a quote options for family testing and detailed instructions. So really, the process of certifying the products technically is not driven by Zaga. We have professional test houses in place that help you with this process. By and large, once you have established the connection with the test house, they will guide you through the process. And Jaap later on will tell you exactly how that happens. By and large, you must provide the manufacturer with a detailed circuit diagram of the Luminaire, a construction diagram of the Luminaire, and a letter of confirmation, typically stating compliance to the requirements in the D4i Luminaire specification. No difficult dragging around with Luminaires in this case. It's a fairly easy check. The test house then uploads, if all the tests are carried out positively, the test summary to the Zaga database, and then the product certificate can be downloaded from the database. And the Zaga database is the source of truth here and allows you to download Zaga-D4i certificates, as well as to check what kind of Zaga-D4i certified luminaires are already available from manufacturers. Turning now to the process of for nodes, it's fairly similar. It's again open to Zaga associate and regular members that have signed the local license agreement. But products need to be D4i certified as control device and be classified as type A or B. And this is to ensure interoperability on luminaires that have two interfaces. Of course, to certify your nodes for D4i, you need to be a DIAA regular or associate member. And Scott explained to you carefully the process that you need to go through to obtain that certification. Once you have that and you want to go for Zaga-D4i certification to show the market the full interoperability of your product, you connect to a Zaga test house. And then to this test house, you typically present information about the node. It's a connector pinout diagram, a construction diagram, a letter of confirmation. This is in case if your product has a certified Zaga-D4i baseplate, Zaga baseplate. If not, a sample is needed. And the test house uploads then the positive test results and then certification in place. I hope in this talk to have explained the benefits of Zaga-D4i standard and certification. It creates a simple plug-and-play way of adding nodes to a luminaire. It is available as an open standard to drive scale and innovation, provides for interoperability across vendors, simplified specification and tender process, and allows selection of luminaires today that are future-proof to the technology advances of tomorrow. Most of all, I hope to have also shown you that Zaga-D4i certification is easy to do, and it's worthwhile to do as it provides assurance to the markets that luminaires and nodes from different vendors will work well together. And we are then also delighted to see that a great uptake has taken place of the market in this proposition, both in terms of product availability and in terms of market demand. Thus, from the Zaga website, we see that currently approximately 15 vendors have certified products, Zhaga-D4i certified luminaires available, and by now they have certified around 80 of such luminaire families. All this is supported by a strong ecosystem of Zaga receptacles, base plates and caps, and D4i LED drivers. We also see it's required in many tenders. Okay, this concludes my talk. Thank you for your attention. I have mentioned the test houses a number of times and the excellent support they give you. I then hand over to Jaap Nussink from DECRA to show that it is really true and that they provide, and he can tell you how they provide this help. Okay, Jaap, handing over to you.
Thank you, Day. So I hope everybody can see my screen. I'm Jaap Nussink from DECRA in the Netherlands. My job is business development and sales for the lighting team. So who's DECRA? I will just give a short introduction. DECRA is a worldwide certification organization. Started in Germany in automotive testing and certification, and bought Kima 10 years ago, somewhat like that, in the Netherlands. That was the company where I originally worked, and then added lots of certification services in electrical testing, EMC and wireless, and all that kind of services. Quite a big company in the meantime, almost 50,000 people working for the company worldwide, and we have laboratories in Europe, China, and many other areas in the world, US, etc. So let me shortly take you through Zaga certification. What is the certification process? You've already heard a lot about it from the two colleagues. I just want to explain how we can help as DECRA and how we can assist. And of course, I speak for DECRA, but all the test houses that were listed most of the test houses can offer the complete service as well. So if you look at the different components, I've taken here also the outdoor example as a basis. However, it's not much different for the indoor version. So book 20, book 18 are basically have the same content. On the right side, you will see the Luminaire, and in this case, the three components that we started out with, which is a receptacle, a connector, and the cap to close the connector. Those are basically tested by a test house and can only bear the Zaga trademark or certification mark. For this, you have to go to an accredited test house where you test, where the test house will do the testing. As you can see on the left side, the test lab will do the testing and will take care of the listing on the website of Zaga. And as soon as it's publicly listed, you can use this for the use of the certification mark. And you can also print out a certificate from the website if you need to show somebody that your product is certified. Moving on to D4i for drivers. In that case, it's you have two options. One option is self-testing, so you can do the testing all yourself and then submit the report to the DIAA. So that's one option. The other option is testing by an accredited test house, so that DECRA could do the testing for you, but still you have to submit the test results yourself to the DIAA, and the DIAA will then take care of the listing on the website. So the certification in the end takes place on the DIA website, and you can start to use the D4i trademark as soon as it's publicly listed on the website. Then the certification process for Luminaire, that's again also very simple. You submit the information to the test lab. We will do the testing and then do the listing of the product on the website. Also here, it's just a simple, straightforward process. So testing is always done by the accredited test house and then listed on the website. Then the certification process for a node, and then D4i only. So that's only the electronics that are in the node. There you again have the two options. Option one is again self-testing by the customer. So you can do the full test yourself and then submit the results to the DIAA, and the DIAA will then take care of listing of on the website. And as soon as that is done, the trademark can be used. In the option two, you can basically subcontract the testing to a accredited test house. And in that case, you still have to submit those results yourself again to the DIAA for final certification. Last one is the certification process, Zhaga-D4i for the nodes. In that case, you have also two options, but here it's a little bit more complex. The first option is you subject the testing of the electronics, or you do the testing of the electronics yourself, submit the report to the DIAA. The DIAA takes care of listing on the website. And then you can go into the process of the finalization, so testing by third-party test lab on the Zaga requirements, and then get the listing on the Zaga website. The last two parts will then be done by the accredited test lab. In option two, you can also subcontract the D4i testing in the third-party test lab. In that case, the test lab does the test. Again, you have to submit yourself the test report to the DIAA, and the DIAA will then take care of the listing. And in the meantime, the testing for Zaga requirements can be done, and the listing on the website can be finalized as soon as the DIAA listing is realized. So basically, this can be a little bit faster than doing it in two steps. So doing it yourself first and then list on the website, because in the other case, in the option two, we can combine the testing of the electronics together with the testing of the Zaga specifications of the mechanics. And that concludes my presentation. And then I would like to give back to Tim.
Hello, sorry, I was struggling to unmute myself. Thanks very much, everybody. Thanks for 3 great presentations. We got lots of questions. If you have more questions as we go through, please type them into the Q&A box. We will try and answer as many questions as possible. And let's start now. So this one is probably for Scott, I think. Referring to Luminaire data part 251 containing pre-stored Luminaire information. Does the specification indicate how to manage this information when multiple control gear are inside the same Luminaire? Is this covered in the test specs?
So the requirements for Luminaires, yes. So the control gear itself is supplied to the Luminaire manufacturer with the memory bank empty. And there's, in our D4i requirements, there's a minimum set of information that needs to be in there. And the GTIN is the minimum, which is pretty simple, but it is recommended to put more information into the memory bank one about the Luminaire and the lamp. Okay.
Okay. This is a question for Day. Can you better describe the relationship between Zaga and ANSI 136.41? Is it expected a certification program will also appear for this?
Yes, thank you for the question. Yeah, so as I shortly indicated, we are in the process of also including in our specification an architecture which has the C136.41 included. This is currently in its final stages, the specification, and it's going out. It has gone out for IPR review technically just a few days ago, and I expect the ratification of this spec in April. Yes, we will also develop or announce a certification program around this as soon as the spec has been completed. And this will allow you then to certify additionally to what you can currently already certify, which is Luminaires with one or two of the traditional Zaga interfaces. It will also allow you to Zhaga-D4i certify a Luminaire with an ANSI interface on the top and an additional Zaga interface. Similarly, we will develop next to the certification Zhaga-D4i certification program we have for nodes right now, also the Zhaga-D4i certification for NEMA nodes that are compliant with the electrical architecture that we have prescribed in this update of book 18. Again, adhering to our if it fits, it works promise. So that is it for me. Thank you.
Okay, next question. Relating to part 150. Why is part 150 optional? Some drivers, sorry, the screen just moved. Yeah, why is part 150 optional? Some drivers might not be compatible with certain D4i sensors or nodes.
So part 150 is optional inside the driver, but not inside the outdoor luminaires. So the Zaga-D4i Luminaire for outdoor, the book 18 type, must have an auxiliary power supply in the Luminaire, but it's a choice how that's achieved. So it could be achieved by selecting D4i drivers that include that, or by adding an additional component, which is just an auxiliary power supply. So the sensor always has the auxiliary power available. Those luminaires have that pin connected up regardless of how it's achieved inside the luminaire.
Okay. There's a question about book 20. The dimensions for each sensor. There's a dimension with the cutout and the size, but are these maximum dimensions, minimum values? More specifically, does the height of the node need to be as per the specification, or is this a maximum delimitation?
Yes, thank you. I didn't cover all the technical details, nor will I give the impression here that I know all the details. So please, in case of really detailed questions, consult the specifications where it's all complete. For the luminaire cutouts, these are the I think maximum dimensions that we have. And no, these are of course the minimum dimensions, because the node must fit in, and then for the demarcation module this would be maximum dimensions. As to the protrusion limits, these have been set and specified. I didn't talk about that. These have been set. There's currently still some debate about these in relation to NEMA specifications. So I'm sorry, I cannot answer here everything in full detail, but please consult the specs or get back to me in writing, and then I can look up the details.
Okay. This might be a question that Jaap might be able to answer. Which directives apply to certification for luminaires? EMC, oh, I'm sorry, my screen just jumped when I was reading out. EMC or LVD or RED?
Interesting question. EMC and LVD is applicable. Also, it can be the RED depending on what you're doing for the rest in the luminaire. So you have to look at the complete product then, but normally it would be EMC and LVD, and the RED will be applicable to the sensor. But basically that is separate from the Zaga certification. It has got nothing to do with the Zaga certification itself, and also not with the D4i certification. So the legal requirements in Europe are not taken into consideration for Zaga certification. That can also not be done because the Zaga and D4i certification are valid worldwide. You can use them worldwide, while the EMC and LVD and the RED are European certification schemes.
Okay. Another question. Please correct me, please say if I understand correctly. To certify Luminaire, a company must be in the Zaga consortium, and then we have to certify the Luminaire family via DECRA, and then with that certificate sent to Zaga consortium. How long is the process approximately to certify an outdoor Luminaire?
Interesting question. I can only answer for DECRA in that case. Normally certification for Zhaga-D4i is 3 weeks for a Luminaire. And you don't have to send a certificate to Zaga because we will take care of the full Zaga certification. So basically, in the end, when we are done, you will have a listing on the Zaga website, and you can use the trademark. And you can, if you want to have the certificate, you can print it from the Zaga website.
Okay, thank you. Is it necessary for Zhaga-D4i certification of an outdoor Luminaire that it must have 2 Zaga receptacles?
No, it doesn't. You only need 1, but you can have 2.
Okay. All right, this is a question for Scott. My understanding is that DALI 2 drivers do not need parts 251, 252, 253. This is optional, but it is a requirement for D4i. Is there not a danger that a project mixing DALI 2 devices and D4i devices does not give consistent reporting?
So if you're developing or designing an installation, you select the drivers or luminaires that provide the features that you need. So in our product database, you can see exactly what you're getting for each product, which parts of the standard are implemented. So if you look for, if you need energy and power, that's part 252, just select that. And then you'll find all drivers, whether they're D4i or DALI 2, you'll find all drivers that implement the energy and power part of the standard. So I don't see any danger there. It's quite clear what you're going to get.
Okay. Here's a good question. What wireless protocols are being used with D4i?
So there's actually wireless activity within DIIA just now. So we're looking at 2 main solutions. One's called a gateway and the other's based on the IP 62386 part 104 with solutions for Thread, Bluetooth, Mesh and Zigbee, which are in progress. They're not ready yet. But for these types of outdoor applications, other wireless protocols are more likely to be used. So some of the narrowband, the wide range, the citywide type applications or radio formats. And they're not standardized as part of D4i or Zaga-D4i. You've got a choice of the radio system you use. We don't limit that. Okay.
Okay. Do you have anything to add on that, Day, about the wireless protocols?
No, I fully agree with Scott's result, and there's a lot of action there in the DALI Alliance, and it's very interesting developments, and that would help to take the interoperability 1 step further. We in Zaga currently focus on the interface between the nodes and the luminaires, and one of the strengths of this approach is that we're agnostic as to what kind of communication technology would use, and can that be decided by a customer in a next step after having decided on his Luminaire technology. So we as Zaga do not fully enter in this field.
Okay. The next question The certification of a control device is only for part 351 and Zaga conformity. It doesn't say anything about the functionality and available data in the control system. If you can imagine that being a question, Scott.
Yeah, I'm not quite sure what the question is there.
Well, maybe
so control devices also need to implement parts 101 and 103. So it's not just part 351. You need to implement those 3 parts as a minimum. It's optional whether or not the manufacturer builds in sensor technology. For example, one type of control device for outdoor luminaires might just be a time clock, something like that. And there's no sensor in there. So that's permitted. We don't disallow this kind of product. But you can also build in light sensors, occupancy sensors, or other types of sensor into those devices, those nodes or control devices. So it's not limited to what you can do. Okay.
Okay. What if a product fails a test scenario, which is very rare to occur on the actual system? Can we get waivers for that and proceed for certification?
So test waivers are only available where there's a fault with the tests themselves. So our tests for DALI products are very complicated. It depends on the type of product, but tests typically take a few days on the test system to execute for an LED driver, for example. If there's a failure and you believe it's not the fault of the product, but is a fault of the tests, then you need to contact us and we'll check that. There are a small number of known issues with the tests on our website, so please check there first. Otherwise, if you are convinced it's a fault with the test that's not listed, just let us know and we'll look into it.
Okay. As the question which seems to be addressed today, did you speak about an adjustment to the Zaga Book 18 connector for nodes on top?
It's not an adjustment to the connector. It's including a different connector, the ANSI C136.41, into the architecture. So the Zaga connector, as we've had this in our specification in the architecture, is as it was originally published, I think, in 2018. But we add an additional option, which is this ANSI 136.41 interface, a different connector. And we have this only if you, in addition to a Zaga connector on the Luminaire. So there's demand for in the market for that, and that is that you can use existing on-off controllers in your Luminaire and still also offer additional functionality through this second Zaga interface. And so that is for book 18. For book 20, we have developed a new connector, and that is absolutely fit for purpose for this plug and play interoperability in the indoor cases. So there, the new connector is there. It's available currently from vendors and as a certified product, and you can check this on our database.
Okay, thank you. I think maybe this one is for Scott. I think it's related to one of the data parts. As this standard will not set accuracy demands, couldn't it oblige manufacturers to provide information in their data sheets?
Yes.
To find any data on the energy or voltage peaks measurement accuracy.
Yeah, so this is applying to parts 252 and 253, the energy, power, and diagnostics parts. So we specify how to report this information, the power, the energy, voltage, and so on, including the formats, but we don't specify accuracy requirements, and that's quite deliberate. Our members don't want us to specify accuracy requirements. That's manufacturer specific. And the question is about including this in the data sheet, and that's a good point. We haven't added a requirement that the manufacturer shows that in the data sheet, but we'll consider that for the next update. So thanks for that.
Very good. I think we have time for one last question, which I had lined up and I've lost it. Here we go. I think this is for Dave. For indoor luminaires, why the restriction to only one node? When also here a sensor and communication functions are used in practice. Yeah, anyway, let's just take the question, why the restriction to only one node?
Because our committee has judged that the number of use cases are a majority one node only, and that simplifies the specification. So you have to balance always in these specifications the complexity of your specification and the amount of use cases covered. And so in this case, the committee decided that one node was sufficient to cover the majority of the use cases and has selected this for a somewhat simpler specification. But obviously, should we learn from the market that there's a huge demand for luminaires with two interfaces, should we have made a too conservative choice here, then we would definitely take on this challenge and to also look into options with two interfaces. We're an open consortium, inputs are welcome, and inputs are taken into consideration when developing our standards roadmaps.
Okay, excellent. So looking at the clock, I think it's time for us to conclude the webinar. As we said earlier, we did get a lot of questions and we will provide some written answers for as many of those questions as possible in due course. We will also make the presentation materials and the recording of the webinar available via our websites as quickly as we can. So it just remains for me to thank very much the three presenters, Scott, Day, and Jaap, and to thank all you for attending. Thank you and goodbye.
Thank you.
Thank you, also on my behalf. Bye-bye.
Bye.